Now let's move on to question number 31. Now let's move on to question number 31. This is related once again to the hydrogen spectrum. The question says the first emission line in the atomic spectrum of hydrogen atom in the bracket series EAPCET. First of all, according to Rydberg's equation for an electron transition, nu bar equals to 1 by lambda, that's equal to RH into Z square, this Z is atomic number, into 1 by N1 square minus 1 by N2 square, right? And the first emission line of the atomic spectrum of hydrogen bracket series appears at what wave number, right? This is what the question is. Now, so suppose if we, now it is a bracket series. For bracket series, here we have a series of lines called Lyman, Balmer, Paschen, bracket, Fund. For bracket series, this N1 is equal to 2 and N2 is equal to anything, N2 is greater than 2. And but here it says the first emission line. First emission line means this greater than 2, that will be equal to 3. So N1 equal to 2 and N2 equal to 3, when you substitute, this becomes equal to nu bar equals to RH into hydrogen atom Z is equal to 1. So it is 1 by 4 minus 1 by 9. So this is 5R by 36. So 5R by 36 is the correct answer for nu bar. So from this relation, the wave number for the first emission line, that is 322, that is 322 in bracket series of hydrogen atom, the wave number will be at 5R by 36. So the correct answer is option 3. Now let's move on to question number 32. This question number 32 again relates to the quantum numbers. Which of the following set of quantum numbers belongs to highest energy? Highest energy means it should be of highest principal quantum number. Higher the principal quantum number, higher is the energy. So in this, normally what we take into consideration is n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. Like that, when you take normally we consider that 1 greater than 2 greater than 3 greater than 4. But when it comes to the overlapping of orbitals at certain stages, we have overlapping of s and p orbitals of different energy levels. Then what the criteria we should take is that higher the value of n plus L, higher is the energy. This is the most appropriate. Higher the value of n plus L, then higher is the energy. Right. Now, in the first option, if you look at it, n is equal to 3, L is equal to 0. So, n plus L in the first option is 3 plus 0, that is 3s. And in the second option, it is n is equal to 3 and L is equal to 2, that is 3 plus 2, that is 3d. Third option, that is n is equal to 3 and L is equal to 1, 3 plus 1, that is 4, so it is 3p. And fourth option, it is n is equal to 4 and L is equal to 0, it is 4s. Now this, if you take, so this is 3, this is 5, this is 4, this is 4. So this is 3 plus 2 is the highest value, that 3d, right? So this is the highest energy level. 4, and in the sequence also, according to Auber rule, we say 4s is less than 3d. Very clearly we write. So the correct answer is option 2. Now let's move on to question number 33. This question number 33 is regarding the charge and the electron. Again, the basic concept. Certain particle carries 4.8 into 10 power minus 19 coulombs of static energy. Charge on the particle is 4.8 into 10 power minus 19 coulombs, and charge on the electron is 1.6 into 10 power minus 19 coulombs. So how many electrons are present in this particle? So number of electrons present on the particle is equal to charge of the particle by charge of the electron, that is equal to 3. So the correct answer is option 4, 3 electrons. Now let's move on to question number 34. This question number 34 says, this relates to photoelectric effect. A photon of energy 21.2 electron volts strikes a metal surface, resulting in the ejection of an electron which moves with a kinetic energy of 5.6 electron volts. What is the value of work function? For this, here we have is the energy of the incident radiation is equal to work function plus kinetic energy. This is, on the other way we write h nu is equal to work function h nu naught plus kinetic energy half mv square. Where this is the work function, this is the nu naught is otherwise what we call threshold frequency, and this is the work function. So here kinetic energy is given, incident radiation energy is given. So according to this equation, if you substitute the values, energy of the incident radiation is 12.2, which is equal to work function, and the kinetic energy of the ejected electron is given as 5.6. So from this, W is equal to 21.2 minus 5.6, that's equal to the 15.6 electron volts. So the correct answer is option 4. Now let's go to question number 35, which is again related to quantum numbers. The question asked is, principal, azimuthal, magnetic quantum numbers are respectively related to. Principal quantum number n, that's directly related to the radius of the orbit. So it is the size of the orbit, in which we have different subshells that we define as S, P, D, F. S has a different shape, D has S is a spherical, P is a dumbbell, D is double dumbbell, like that. That is what we will given as L, that is shape. And then again here, so here it is size, first orbit, second orbit, third orbit, fourth orbit, so on and so forth. Here in each orbit we have different subshells S, P, D, F. So this is the shape, right? And in each shape again we have different sets of orientations. So that M is orientation, S being spherically symmetrical has only one orientation, but S is spherically symmetrical, spherical being one, it has only one orientation, but P being a dumbbell has three orientations, Px, Py, Pz, and D has orientation as Dxy, Dyz, Dxz, Dx square minus y square, and dz square. These are the orientations. So n relates to size, that's principal quantum number. L relates to shape, that is SPDF. M is equal to orientation along the different, around the nucleus at what different orientations. So they are related to size, shape and orientation. So the correct answer is option 1. Now in the question number 36, what it says is, which one of the following is a centrifugal force balancing the Coulombic force of attraction of an electron revolving in a circular orbit of hydrogen atom? This relates to Bohr's theory, where the centrifugal force is given as minus mv square by r and centripetal force is minus e square by r square. So this we relate while deriving the expressions for energy of the electron, radius of the orbit and other parameters using the Bohr's theory. And the very basic concept on which this Bohr's theory has got the advantage over the previous theory is that why the fast moving charged particle like electron is not losing energy continuously. For that the explanation is given is why the path is not getting reduced. For that the explanation given is that the centripetal force is equal to centrifugal force. Minus mv square by r is equal to minus e square by r square. So it is the centrifugal force and the centripetal force equality is what is given. And so the centrifugal force is equal to minus mv square by r. So the correct answer is option 2. Now let's move on to question number 37. According to Bohr's theory of hydrogen atom, the Rydberg constant RH is equal to, see, already we told, in the Rydberg's equation what we say is nu bar is equal to RH into z square into 1 by n1 square into 1 by n1 square minus 1 by n2 square. This is derived from Bohr's theory. When it is derived, here what we obtain that it is equal to 2 pi square, this RH is equal to, in this RH is derived as equal to 2 pi square me power 4, 2 pi square me power 4 by ch cube, because this nu bar is a wave number and E is equal to hc by lambda or hc nu bar. So when this is Hc nu bar, so when you are converting this nu bar into energy term, it has to be multiplied with Hc. So when you multiply it with Hc, then what you will get RH as 2 pi square me power 4 by Ch cube. So the correct answer is option 1. Now let's move on to question number 38. The wave number of lowest energy line of emission spectrum of hydrogen atom in Lyman series of lines. So again, Rydberg's equation, when you take nu bar is equal to RH into Z square into 1 by N1 square minus 1 by N2 square. For hydrogen atom Z equals to 1, and here it says Lyman series of lines. For Lyman series N1 is equal to 1 and N2 is greater than 1. And here it is the lowest energy line. Lowest energy line means the energy levels, when you have it like this, for this transition and this transition, if you compare, this is the lowest energy level. So as you keep moving away, the energy difference increases. So this is the lowest energy level. So this is N1 is equal to 1 and 2 is equal to 2. So when you substitute the values of 1 and 2, for nu bar, what you will get is RH into Z square. For hydrogen it is 1 square into 1 by 1 minus 1 by 4, that is 3 by 4. So it is 3R by 4. So nu bar is equal to 3R by 4 is the correct answer. So the correct answer in the option says option number 2. Now let's move on to question number 39. Now the question number 39 says, which one of the following regions of electromagnetic radiations the line spectrum appears when the electron transition occurs from n is equal to 5 to n is equal to 1. So this is again hydrogen spectrum related. When you have the different energy levels like this, 3, 4, 5, then any line, any higher energy to lower energy, when you have, this is, all these lines we call the Lyman series of lines. All these are observed in UV region. And if the transition is from any higher energy to n equal to 2, this is what we call Balmer series of lines, which is in the visible region. And this is Paschen. This is 1, 2, 3, 4, 5. Paschen, this is near UV. And this is UV. Then like this we get Lyman, Balmer, Paschen, bracket, Fund. Like this we will get. Now the question is from n is equal to 5 to n is equal to 1. So this is Lyman series in the ultraviolet region. So the correct answer is option 1. Now let's move on to question number 40. This is once again related to quantum numbers. Which one of the following is the incorrect set of quantum numbers? N equal to 2, L equal to 0, M is equal to 0. First of all, N will take the values 1, 2, 3, 4. Then L will take the values from 0 to n minus 1. And M take the values from minus L, 0 to plus L. These are the things. So when n is equal to 2, L can be 0. When L is 0, M can also be 0. Right? Then second option, n is equal to 3. When n is equal to 3, L can be 0. When L is 0, M again can be 0. Then third option, n is equal to 2 and L is equal to 1. When n is equal to 2, 0 and 1 are the possible ones. So this is possible. When L is equal to 1, M can be 0. So third option is also possible. When n is equal, fourth option, when n is equal to 3, L is equal to 1, it is possible. When n is equal to 3, L can be 0, 1, 2. So it is possible. And when L is equal to 1, M should be minus 1, 0, plus 1. But here M is equal to plus 2 is given. For L is equal to 1, M is equal to plus 2 is not possible. So the incorrect set is option number 4. Now let's move on to question number 41. Which one of the following represents the least angular momentum of electron with set of quantum numbers L equal to 3, M equal to 0 and S is equal to plus half. So this is when L is equal to 3, then the possible values of n what you can have is n can be from 1, 2 and 1, 2, 3, 4, etc. Then L is having a value of 3 and M is having a value of 0, right? And S is having a value of plus half. So the electron is in the L is equal to 3 means it must be 4f. It is 4f. Then which one of the following represents the least angular momentum? Least angular momentum is 2h by pi. So because MVR angular momentum MVR is equal to NH by 2 pi. So N is 4h by 2 pi. So it is 2h by pi is the the angular momentum, right? So the correct answer is option 4. Now let's move on to question number 42. What is the uncertainty in momentum of electron if the uncertainty in position of it is infinity? This is again an uncertainty principle according to which we wrote delta x into delta p is equal to h by 4 pi if you take the equation. Then what it says is that this is the product of uncertainties in the position and momentum. In the question, uncertainty in the momentum of electron is infinity. This is infinity. Then delta x is equal to h by 4 pi into infinity. When this is 1 by infinity, this is equal to 0. So uncertainty in the position will be 0. So the correct answer is option 3. That means the position can be determined exactly. When you determine the position exactly, then the uncertainty in the momentum what you determine, that means the value what we got is highly inaccurate. That is what the infinity in uncertainty, infinity in accuracy, infinity in inaccuracy. And similarly, if position uncertainty in position is infinity, then uncertainty in momentum will be 0. So if one is 0, the other one will be infinity. So the correct answer is, again, I'll repeat that the answer is option 3. Now let's move on to question number 43. Now here we reach it after completing these single answer questions. Now we reach to other type of problems likely to be asked in competitive examinations. This is a matching type question, very good. Here one has to be careful that all the options that we should know perfectly. So now on the left side, certain concepts have been given, and what is the formula or what are the characteristics relating to that particular concept is what is given in the list 2. Balmer series of lines. Balmer series of lines in the hydrogen spectrum is obtained in the visible region. Lyman series of lines are obtained in ultraviolet region. De Broglie relationship is lambda is equal to h by mv. And angular momentum of electron is nh by 2 pi. MVR is equal to nh by 2 pi. So Balmer series relates to visible region. So A must be 3. With A 3, there is only one option. So that option 3 must be the correct answer. A 3, that is visible region. Then B 2, Lyman series in the ultraviolet region. And de Broglie relationship lambda is equal to h by mv. So that is at option 5. So C5 and angular momentum D is equal to nh by 2 pi. So D1. So the correct answer is option 3. Now let's move on to question number 44. Now in the question number 44, it is given about the different principles what we learn in the chapter of atomic structure, uncertainty principle, Pauli's exclusion principle, Hund's rule and Haber principle. What Haber principle says is that while filling up of the electron into different orbits, the least energy level is filled first. So for Haber principle, the correct related to is that the option 2, in the ground state of an atom, the orbitals are filled in order of their increasing energies. And what Hund's rule says, pairing of electron can take place only when all the lower energy levels are completely filled first. So Hund's rule is corresponding to the option 1 on the right side. So that is A2, B1. And Pauli exclusion principle, no two electrons can have all 4 quantum numbers same. So C must be 3. And uncertainty principle, it is impossible to determine the position and momentum of electron simultaneously. So it must be 4. So the correct answer must be option 2. Now let's go to question number 45. In the list 1, it is given Planck's constant. Planck's constant is 6.625 into 10 power minus 34 kilogram meter square per second. So A must be equal to, A relates to option 4 in the list 2. So A must be 4. With A4, we have two options 1 and 3. And Rydberg's constant is 109,677 centimeter inverse or 1096.77 meter inverse. So B must be 2. A4, B2. So answer must be option 3. That is 4, 2. Let's see C and D also. Let us check. E by M ratio. E by M ratio, the charge to mass ratio, that should be the 1.6 into 10 power minus 19 divided by 9.1 into 10 power minus 31. That comes out to be 1.75 into 10 power 11. So C must be 3. So A4, B2, C3. Yes, it is there in the option 3. And 4. Ground state energy of electron in hydrogen atom, that is minus 13.6 electron volts. So it must be option 5 on the list 2. So when you relate all that 4 now, A4, B2, C3, D5. So the correct answer is option 3. Let's go to question number 46. In this, on the left side, it is given about the quantum numbers and wave functions. On the right side, corresponding their characteristics are given. It's azimuthal quantum number. Azimuthal quantum number relates to the shape of the orbital. So A must be correlated with the shape of the orbital. A must be 3. Magnetic quantum number is related to spatial orientation. So it must be, B must be 4. And the radial probability distribution function, that must be 4 pi r square dr psi square. So C must be 2. And eigenwave functions. Eigenwave functions are related to the accepted solutions to the wave functions. So D must be 1. So the correct answers must be azimuthal quantum number shape A3, B4 spatial orientation, C radial probability C2, and D1. So the correct answer must be option 3. Now let's move to question number 47. Now let's move on to question number 47. In the question number 47, again on the matching type, on the left side what it is given is about the different characteristics, and the corresponding formulas are given in the list 2. Angular momentum of electron, that must be mvr is equal to nh by 2 pi. So A must be with 3, A must be matched with the 3 in the list 2. De Broglie's equation lambda is equal to h by mv, so it must be related to, B must be to 4, right? A to 3, B to 4, and first Bohr orbit is equal to minus 13.6 is the energy, but it is given radius of the orbit. So radius of the orbit means it must be 0.529 angstroms, that is 0.529 into 10 power minus 8 centimeters. So C must be 2, A3, B4, C2, D energy of electron in the nth orbit, that is minus 13.6 by n square electron volt per atom. So D must be 2, 1. So A3, B4, C2, D1. So the correct answer is option 4. Now let's move on to question number 48. Here we have some assertion reason type questions. In this, two statements are given. One is called assertion, another is called reason. Assertion means whatever the fact that we observe, is it right or wrong, and what is the reason for that fact, that will be given under reason. So if that assertion given is right, then A is correct. If reason is given is also correct statement, then reason correct is what we have to write. And if that reason is the correct explanation or not is also what we have to find out in this kind of questions. So now if you look at it, assertion given in this question is that the value of charge to mass ratio of an electron is 1.7 into 10 power 11. Yes, it's correct. The value of charge and mass of an electron is independent of cathode material and the gas present in the cathode ray. No. Assertion is correct because charge to mass ratio, that is E by M, E is equal to 1.6 into 10 power minus 19 coulombs. Mass is 9.1 into 10 power minus 31 kg. So E by M is, if you calculate, we get it as 1.75 into 10 power 11 coulomb per kg. So assertion is correct. But the value of charge in the reason it is given that the value of charge and mass of an electron is independent of cathode material and the gas present. No, it's wrong, because it depends on the the charge and mass of electron is dependent on the cathode material, and because depending on the what metal that we use, we get the charge. So it is dependent on the material that what we use. So reason is wrong. So assertion is correct and reason is wrong. So the correct option here is the option 3. Now let's move on to question number 49. This again assertion reason type. In the principal quantum number n is equal to 3 and azimuthal quantum number L is equal to 0 represents a spherically symmetrical orbit. The shapes of s orbitals are spherically symmetrical. Yes, when n equal to 3, L will have the values 0, 1, 2, because L will from 0 to n minus 1, and here it is given L is equal to 0. L is equal to 0 represents as 1, P, 2, D. So it is 3, 0. So it is 3s orbital. So it represents s orbital. S orbital is of course spherically symmetrical. So assertion that the principal quantum number n is equal to 3 and L is equal to 0, that represents in 3s orbital, that is 3s spherically symmetrical. Now s orbital being spherically symmetrical, that is reason it is given the value L is equal to 0. So s orbital is spherically symmetrical, so as reason that it is given this quantum number s. So statement 1, that is assertion is correct, reason is correct, and because it is spherically symmetrical, it has got the value 0. So that reason is the correct explanation for the assertion. So the correct answer must be option 1, that is both A and R are correct and R is the correct explanation of A. Now let's move on to question number 50. This question number 50 is again assertion reason type, where in the assertion it is said that Bohr proposed that angular momentum of an electron is quantized. Yes, angular momentum of an electron is quantized. MVR is equal to NH by 2 pi. The motion of electron is restricted only to those orbits whose angular momentum is the integral multiple of h by 2 pi. The motion of an electron is restricted only to those orbits whose angular momentum is an integral multiple of h by 2 pi. Yes, it is. That's correct, because in the other it cannot have. Only where MVR is equal to NH by 2 pi, where n takes values of 1, 2, etc. Those orbits only that electron will take. In between it cannot take. That is what the Bohr's theory says. So both assertion and reason both are correct, and reason is the correct explanation for assertion. So the correct answer must be option 1. Now in the question number 51, which is again assertion reason type, where it says the general expression for the total energy of electron En. According to Bohr's theory, as we told, En is equal to minus 2 pi square me power 4 by n square h square, which is on substitution of the values we will get it as minus 13.6 into z square by n square. Of course, if it is a hydrogen like atom, then we get the value of z also by n square. Now for hydrogen atom, we say that z equals to 1. So En we write it as minus 13.6 by n square, which is minus 2 pi square me power 4 by n square h square. This is the correct formula. The total energy of electron, for any particle, the total energy of electron is of course is equal to kinetic energy plus potential energy. When you take kinetic energy and potential energy adding up, then only we will get this formula. So the formula is correct, and that is nothing but represents the sum of the kinetic and potential energies. So assertion is correct, reason is correct, and reason is the correct explanation, because without that we don't get this formula. So it is the correct answer is option 1. Now let's move on to question number 52. Now here we have some multiple answer questions, means more than one option is correct. Now this question relates to electronic configurations. Which of the following pairs of elements has exceptional electronic configurations? Exceptional electronic configurations in the periodic table we have for certain elements like chromium, copper, silver, palladium, platinum. For all these elements we have the exceptional configurations. So in this, chromium and cadmium. Chromium is having exceptional but not cadmium. Chromium and copper, yes, exceptional configurations. 4s1. In the chromium we have, without 4s is completely filled, we have electron in the 3D, that is 4s1 3d5 due to half filled configuration. And copper we have again, instead of 4s2, what we have is only 4s1, but it is 3d10, which is normally supposed to be 4s to 3d9, but Again we have an exceptional of 4s1 3d10, and for silver again we have it is 5s0 3d10 is what we have for silver. So the exceptional configurations without 5s, here we have completely filled 3d. So like this we have that chromium, copper, silver, these are the ones we have exceptional configurations. Iron and cadmium are not having exceptional configurations. So the correct options here, the correct pairs here are option 2 and option 3. So now let's move on to the question number 53. Which of the following statements are true concerning the Rutherford's model of an atom? In Rutherford scattering experiment, zinc sulfide is a fluorescent screen is used. Yes, the alpha rays have been projected to the zinc sulfide through metal foil behind which a zinc sulfide screen is kept, where the scattering and reflected pattern is observed on that screen. Narrow beam of beta particles are used for scattering experiment. No, it is the alpha particle that is used. The positive charge in the atom is concentrated at the center. Yes, it is correct. Electrons in the nucleus are held together by electrostatic force of attraction. Yes, that is also correct. So it is the options 1, 3, 4 are the correct. It is the zinc sulfide fluorescent screen that is used, and the positive charge in the atom is concentrated at the nucleus. That's what at the center. Electrons are revolving around the nucleus and which are held by electrostatic force. So the correct answers are option 1, 3 and 4. So now let's move to the question number 54. Now let's go to question number 54. This is again a multiple answer question, and this relates to black body radiations. Which of the following statements are not true concerning the black body? As the temperature increases, the peak of the curve intensity versus wavelength shifts towards the lower wavelengths. Yes, that's correct, because here when a black body graphs, if you look at it, the intensity versus wavelength, this is the intensity and this is the wavelength. When a graph is drawn for black body radiations, like this, the curves will be there, right? This is the maximum intensity. This is what we call lambda max. This is temperatures T1 and T2 if you take. Then here T1 is greater than T2. So here what happened is that with increase in temperature, the peak shifts towards the lower wavelength, towards the left. Here this is the peak, right? And now here this is the peak. As the temperature increases, the peak is shifting towards the left. So the first option is correct. And at a given temperature, the intensity of the radiant energy increases with the wavelength, reaches maximum and then decreases. Yes, if you observe this, any of these two graphs, with increase in wavelength, the intensity increases, reaches maximum. That's what we call lambda max. And after that, it decreases. At any temperature, it is the same thing. Only thing is, either the curve gets flattened or it will be shifted either left to right depending on increase or decrease in temperature. The position of the peak may change, but the pattern of the peak, the pattern of the graph at any temperature, that with increase in wavelength, the intensity is increasing, reaching maximum and then decreasing. So option 1 is correct, option 2 is correct. Now let's see the option 3. As the temperature increases, the peak of the curve of intensity versus wavelength shifts towards higher wavelength. No, it's towards the lower wavelength, not towards the higher wavelength. So it is opposite to the option 1. So that's incorrect. The oscillating particle in the black body emits energy continuously. No, oscillating, this is what is a proof that we given for discontinuous spectrum. The discontinuous nature of atomic spectrum, the discontinuous nature of the radiations. Oscillating particle in the black body will not emit energy continuously. It will emit energy discontinuously. If it emits energy continuously, then the graph we are supposed to get it like this. The graph should be like this, but we are getting it like this. So it's not continuous, it is discontinuous. So option 4 is also wrong. So finally, the correct answers are options 1 and 2. Now let's go to question number 55. Which of the following statements are true concerning the Bohr's theory of the structure of the atom? Regarding the Bohr's postulates and Bohr's theory regarding explanation for the structure of an atom. The first option says the electrons move from a lower stationary state to a higher stationary state continuously. No, they are not continuous. It is as and when, only when certain amount of energy is either given or withdrawn. Then only they will move. Otherwise they don't move. So option 1 is wrong. Second option says the energy of electron in an orbit remains unchanged as long as the electron remains in that orbit. Yes, that's correct. That's what one of the first postulates of the Bohr theory says, that electron not only revolves around the nucleus continuously in a specified path, but as long as the electron is revolving in that specified path, its energy is constant, neither energy is emitted nor energy is absorbed. So, second option is correct. Let's see the third option. The electrons revolve around the nucleus with definite velocities in circular path of fixed radius and energy. Yes, the radius is fixed. Of course, this is against uncertainty principle. Later it is slightly made an objection, but according to Bohr's theory, it is correct that electron will have definite energy, definite velocity, definite distance from the nucleus, and definite number of revolutions that it will make around the nucleus in unit time. So, option 3 is also correct. And the angular momentum of an electron is not quantized. No, the second postulate of Bohr theory says that angular momentum of electron is quantized. mvr is equal to nh by 2 pi. So, fourth option is also wrong. So, the correct options with respect to Bohr's theory, the correct statements are options 2 and 3 only. So, the answer is option 2 and 3. Now, let's move on to question number 56. The energy of electron in the first Bohr orbit of hydrogen atom. Energy of electron in the first Bohr orbit of hydrogen atom. First, for an nth orbit, it is minus 2 pi square me power 4 into z square by n square. Right? Where for hydrogen atom, z is equal to 1. So, En is equal to minus 2 pi square me power 4 by n square h square, and if you substitute these values, we will get minus 13.6 by n square electron volt per atom. So, here minus 13.6 electron volts for the first Bohr orbit when n is equal to 1. If n is equal to 1, then so E will be equal to minus 13.6 electron volt. That is correct. Minus 2 pi square me power 4 by when n is equal to 1 by h square. That is also correct. H square by 4 pi square me square is not correct. 0.529 angstroms, that is the radius, that's not the energy. So, here the correct options are option 1 and 2 only. Now, let's move on to the question number 57. Which of the following are boundary conditions of wave function? In the Schrodinger's wave equation, as we told, dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square to E minus u into psi is equal to 0. This is a second order differential equation that is given for the electron motion around the nucleus in an atom. So, in this equation being the second order differential equation, it will have many solutions, but all the solutions are not acceptable. But for this equation to solve, the psi must be single valued, and the psi must be discontinuous, but the psi must be single valued, psi must be continuous, sorry, not discontinuous, it must be continuous, and the psi must also be what you call single valued, and it is also normalized. So, these are the certain boundary conditions that psi must be followed. So, in this, if you look at it, here psi must be discontinuous is not correct because psi must be continuous. Psi must be finite. Yes, psi must be finite. This is another condition. Psi must be finite. It cannot be infinite. And psi must be single valued. Yes, it should be single valued. And psi must be infinite. No, psi cannot be infinite. Psi must be finite. Psi must be continuous. Psi must be single valued. So, in this, if you look at it, the options that are given is that options 2 and 3 are the correct. Discontinuous is not correct because it must be continuous, and infinite is not correct because it is finite. So, the only options correct are 2 and 3. So, with this, we have done many good questions on both conceptual and numerical part of the atomic structure by covering all important aspects, every aspect in the atomic structure. So, all these questions are highly helpful in solving the questions going to appear in EAMCET and other competitive examinations. So with this, the student must have gone through a well deserved session, and with this I wish you all the best.